All right. Unmuted this time. Remembered it. All right. So, welcome to discussion week 4. This will be our last recorded section, which is great. Hopefully, your homework is going well. If you have any questions going forward, feel free to email me. And announcement wise, you should be working on your observations. Remember, you should have a few done, especially before spring break. You want to make sure you get those in so you can get full observations and be able to record what's happening. I was wrong last week about your ad drop deadline. If you've seen the email from the university, it is actually from February 18th. Don't forget about your homework due Friday. Midterm 1 is being released this week. It'll be released on the 17th and it'll be due on the 25th. During this week's recording, we will be doing some midterm review. And then next week, we will be back in person. So I will see you bright and early at 9 a.m. And I thank you guys for being super accommodating with this. And we'll go ahead and get started. We're going to, during this month, is kind of highlight some Black astronomers as we go through for Black History Month. So this week is Benjamin Banneker. I might have said that wrong. He's an almanac author and astronomer. He was born in 1731 and died in 1806. He calculated tide times, the time of the sunrise and sunset throughout the year, and the phases of the moon, changing positions of planets. Well, in his almanac, he mentioned all of these. The occurrence of eclipses and predictions, seasonal changes, and when pests would likely be returning to houses. And at the age of 58, he forecasted his first total solar eclipse, which is really cool and a really big thing for that time. All right. We're going to start getting content-wise today. We're going to be talking about the phases of the seasons on the Earth and phases of the moon. We have 4 seasons. You may not really see them in California as it's super nice out all the time. But if you're like me and you're from the Midwest, you do get all 4 seasons. You get summer, fall, spring, and the disastrous winters. It can get very cold. So our Earth is tilted. We're not perfectly perpendicular within our orbit as we rotate. So that means during some parts of the year and some parts of the day, parts of the Earth are going to be receiving more sunlight than others. So if you look on our picture that we have here, the side that is tilted closer to the sun will be receiving more sunlight, so it's more likely going to be in a summer month, while the tilt portion of the Earth that is tilted away is going to be cooler, so it's going to be in the winter months. And we typically characterize winter by shorter months, colder temperatures. In summer, we have longer days, hotter temperatures. Yeah, we also so that's what causes our seasons. In places like California, places that are closer to the equator, we don't get as drastic change. We'll typically have like a more wet, rainy season rather than our cold winters. In places like the North Pole and Antarctica, rather than seeing the immediate changes in the seasons, they actually see this in the length of day. So like closer to the North Pole or in the Antarctic, you're going to have days of sunlight that won't last 24 hours. It'll actually last significantly longer, or like seasons of darkness where it'll be dark for super, super long periods of time. You can find some really cool people that talk about it all the time. There's this one TikToker that lives on Svalbard, which is the most northernmost island I think that people live on. And she talked about sunrise and how it was like, it took like a day or two for the sun to actually rise in that area. So phases of the moon, as you know, when you go outside or like sometimes during the day, you'll even see the moon, it'll have a different shape. It'll either be half the moon, a sliver of the moon, the whole moon, or none of it. We are actually always seeing the same side of the moon, which is crazy. We've never actually seen the entirety of the moon. One of the cool things you can do at home, if we were in person, I would try to do this with you guys, but you can get a ball. You can either put it on a stick, you can just kind of hold it in your hand. You will be representing the Earth. What you're holding is going to be the moon, and then your source of light is going to be the sun. And if you take that ball, hold it in front of you, and just kind of rotate your body with that ball, you can see the shadows change on it, and that is depicting our seasons of the moon. So we typically have 8 different phases of the moon, and each of them have their own different name. One that almost everybody can pick out is our full moon and our new moon, when we don't really see one. Change my color. Blue is not very visible. Our half face of the moon we call our quarters. So our first quarter is down here. And we have our third quarter. So the phases of the moon typically go in this rotation. And then in between them, we have our gibbous, which is where the shadow is basically a crescent. So our first is our waxing gibbous. Then moving, we have our first quarter. Past that, we have our crescents, where the shadow is taking up a majority of the moon face, and we only actually see light on a super small crescent. This is our waxing crescent. It's easy to remember waxing versus waning. The waxing will come first, waning after. So after our new moon, we have our waning crescent. Ooh, what is happening? Sorry, writing error. There we go. All right, so we have our waning crescent, third quarter, and our waning gibbous. And you should be able to, whether it's making your own diagram or being given one, you should be able to write down which phase is which and which its title is. So that's a good thing to memorize. All right, so going forward, one moment. You can also go to this link here and do a lunar phase simulator. I won't be doing it in our recording today, mainly because just for time constraints, so we can get to a midterm review as well. All right, so next, we have within these phases 2 cool kind of eclipses. We have our lunar eclipse and solar eclipse. Solar eclipses are a big deal. If you remember, what was it? 2017 or 2019? One of those two. We had a solar eclipse happen. It was really cool that I got to experience it quite well. But rather than having the full eclipse, I had shadows. Like shadows actually changed because what part of the sun was actually hitting the earth was different. So lunar eclipses is when the earth comes between the sun and the moon. You'll typically see these, they're way more common as the big red moon. This is because the light rays that bend around the earth are actually refracted into the red light spectrum. So the moon appears orange-red to us. And then we have our solar eclipse, where the moon is between the earth and the sun. Here, because of the distance between the moon and the earth, we actually get full coverage and our sun is basically completely blocked off. But it only happens on a specific path depending on where you are. So you may not get a full solar eclipse, you may get partial ones. There's cool calendars you can look at to see when the next solar eclipse is. You can like go to places to see the full solar eclipse. It can be real dangerous on your eyes, so make sure you have the correct glasses to be able to view it. So we've talked about the tilt of the Earth, which causes our seasons. Our moon, we didn't talk about this, but the moon is a big cause of our tides. We'll go into the tides after our midterm. Our lunar eclipse is when the Earth is between the moon and the sun, and our solar eclipse is when the moon is between the Earth and the sun. So we're going to practice with this a little bit. So what I want you to do is take what we just discussed and describe why we have seasons and draw a picture to accompany your explanation. Go ahead and do that. Pause the video. All right, So hopefully you paused and went through how to do it. Should be able to explain it, but basically because the Earth, the tilt of the Earth hits the sun during a particular part of the orbit, we have our seasons. And I believe, yeah, lucking out, I have a picture of it. There are other ways to kind of draw this as well. One of the ways I like looking at it is a bit different than this picture here. There's our axis, right? We have our sun. And the sun rays hit. I like drawing all of the arrows going across. You can kind of see how it hits the Earth this way. So you can see at this point, if this is our equator, the summer is going to be in the southern hemisphere. But if the Earth was to be at a different tilt, or a different part of its orbit, we will have in this one, we have our northern hemisphere is getting a majority of the sun. So that's when it's going to be a northern summer, and a northern part of the hemisphere will have a summer, and the southern hemisphere will have winter. Yeah. All right. Next question for you guys is, what is an eclipse? What is the difference between a solar and a lunar eclipse? And draw a picture to support your answer. So I'll go ahead and let you pause and do that. All right. So I'm going to go ahead and draw our two here. Here's our sun. You should be able to draw these to help explain it. Being able to draw a lot of the concepts that we go through will help you overall. And we have our Earth. In our lunar eclipse, remember the Earth is between the sun and the moon. And in our lunar eclipse, the moon is between the Earth and the sun. I'll draw the moon with red. So here we have our moon in the lunar eclipse, and here we have our moon in the solar eclipse. So the sunlight's hitting, and as a result, we get a shadow of the moon that moves across the Earth. And for our lunar eclipse, the sun is hitting the Earth. The light is bending around the atmosphere of our sun at our poles. And this gives us a red colored moon. It's really cool to learn how things are going about. Light is a really cool thing to talk about. So this, let me label them: lunar, solar eclipse. Cool, cool. All right, next, what I want you guys to do is talk about, we're gonna ask this. What is an equinox? I didn't discuss it, so I want you guys to be able to look it up. And how often do we experience them? This has to do with our seasons. Go ahead and try to figure out the answer. All right, hopefully you've had a chance to look it up and look at it. So an equinox occurs twice a year. Typically there are autumnal and in our spring equinox. Our longest day of the year or our shortest day of the year. This is when the sun crosses our celestial equator, and this is when our days and our nights are of equal length. Yeah, it's pretty cool. Yeah, you'll pretty much hear it as a spring equinox or an autumnal equinox. It happens in spring and the fall. Our solstices are when the days are super long in our summer. So our summer solstice, at which point we're going to have our longest day, and our winter solstice will have our shortest day, or like the coldest day of the year, shortest day, shortest amount of light. Yeah, so you should know the difference between our equinoxes and our solstices. 2 times a year, and day equals night. Cool, cool. All right, So next, accidentally had that in there twice. What I want you to do, I'm giving you the diagram, but if you're doing it on your own piece of paper, go ahead and draw it out. But I want you to fill in the phases of the moon in our diagram. Let's go ahead and pause and do that. Also, label the phases. Make sure you're able to label them. So pause, go ahead and do that, and then we'll go over it. Cool. So if we're starting here, this is going to be our full moon. And we're going to move in this direction. Next, we have our waxing gibbous. So we're only going to have a very crescent of darkness. The majority of the moon is still going to be a light. Here we have our first quarter. Then we have our waxing crescent, where only a crescent of the moon is still light and visible to us. We have our new moon, where the entire moon is shaded. We have our waning crescent. Oops, spelled that incorrectly. We have our last quarter, or our third quarter. And we have our waning gibbous. And there are your phases of the moon. All right. If you notice between the sides of the moon that are light versus shadowed, they're kind of opposite in the second half of our cycle. All right. There we go. The only thing is the shadow should be switched on the third quarter in this diagram. All right, so that was all the topics we have to go over. Remember, if you have any questions, feel free to email me. I want to stress as we go into our midterm, units, super important. Make sure you're using your student units correctly and showing all of your work, especially going into this midterm. When you're asked questions on math, if it's short answer, show your work. You never know, you could get partial credit for your work. Some of your work might be right, even if your answer is wrong. So please make sure you do that. All right, so we're gonna go into our midterm review. We're gonna have 3 different sections. We're gonna have true and false, multiple choice, and short answer. These questions all come from your midterm review document, which you can find on B courses. And along on B courses, you can find a topic list. It should have a list of just basically all the topics we're going to be going over in this midterm. I'll make sure it's posted on our section page near this, near our recording, and we'll go ahead and get started. So first, we're gonna have a true and false questions. I have 9 true and false here. I want you to go through, determine whether it's true and false, and then if it's false, figure out why. Why is this statement false? If you can figure out why it's false, you're more likely to learn the content and information. All right, pause, go ahead and go for it, and then we'll walk through them. All right. So, first one, the universe is about 14 billion light years old. Is this true or false? This is false. And the reason why it's false is because of the use of the word light years. It is not, wow. It is not light years old. It's just years old. All right, number 2, at a latitude of 20 degrees north, you will never see a circumpolar star within 10 degrees of the horizon. This is also false. And that is because at a latitude of 20 degrees north, the north celestial pole would be about 20 degrees above the horizon. Circumpolar stars circle the northern celestial pole. Rather, other stars will rise and set, appearing to us. So a star within 20 degrees of the north celestial pole would be circumpolar. Stars could be within such stars that could be within 10 degrees of the horizon. So the statement ends up being false. All right. Number 3, on the equator, stars appear to rise exactly in the east and set exactly in the west. True or false? We're going to do false. The question itself is poorly written, and I know we put it in there. It's just to make you think. So the statement is true at some times of the year, but not at all times of the year because of the tilt of our Earth. It's causing the positions of sunrise and sunset to change during the year. It's a good question to look a bit further into if you have the interest to. All right, number 4. The length of the day is the same in both north and southern hemispheres on an equinox. This is true. We just went over that. All right, number 5. Only circumpolar stars can be seen all year at night from a given location. This is also true. There are some photographers out there who like taking pictures or like getting a video of how stars move overnight over a long period of time. And a lot of these, it's pretty cool because you can see some of the stars are actually circling a specific point. I'll post a link of a video for you guys. But yeah, you can see the star circling a certain point, and it's kind of cool to watch, especially if you're a big outdoorsy person. All right, number 6. The Earth always appears full to someone standing on the moon. This is false. And it's false because basically, if you did the hands-on walkthrough of the moon phases where you saw the moon change depending on the light, basically instead of the object you're holding being the moon and you being the Earth, it's switched. The object you're holding is being the Earth and you are the moon. You're still going to see phases because the light is still going to be reflecting off the surface of the moon in what you're perceiving. All right, number 7. The main reason we have seasons can be ascribed to the tilt of the Earth's axis relative to its orbital plane. That is true. Number 8, Newton's third law relates velocity to acceleration. Remember last week? That is false. Newton's third law is every action has an equal and opposite reaction. And lastly, number 9, astronauts are weightless in space because they're beyond the reach of Earth's gravity. This is also false. Everything in the known universe basically has a gravity. You have gravity, your mouse has gravity, your computer does. How much it affects another object is different, but everything has gravity. So astronauts are not weightless in space because they're beyond the reach of the Earth's gravity. It's just the amount of gravity acting on them is significantly smaller, so they're able to basically float. All right. Next, we have our multiple choice question. So basically, it'll be about 4 on a screen. We're going to pause. I'm going to let you go through and answer them. And then I'm going to go through and give you the right answer. And if it needs a bit of an explanation, I'll go ahead and give one, but most of them don't. All right. Go ahead and pause and figure these out. All right. So number 1, from the equator, the sun appears to pass directly overhead on, and this is going to be our equinoxes. Number 2, Galileo challenged the idea that objects in the heavens were perfectly and unworldly by finding mountains on the moon and spots on the sun. I know in section we didn't get a chance to go over deeply into what Galileo did, but he definitely did in section. Number 3, the sun will be directly overhead at noon in Berkeley. When? 3, the answer is D. Berkeley is not in a place to where the sun can ever be directly overhead on noon, at noon, because we're affected by the Earth's tilt. We're not ever actually going to be directly in the same exact line, in an exactly perpendicular line of sunlight. Number 4, it's midnight and a planet is crossing the meridian. Which planet can you be sure this is not? The answer is C, Venus. This is because all inner planets always appear close to the sun. All right, our next 4 multiple choice questions. Go ahead and pause, try to figure them out. All right, so number 5, it's noon and the moon is just setting in the west. What is its phase? The answer is C. it should be its third quarter. Number 6. A solar eclipse can be seen from Africa this March. Which of the following is true on that day? The answer here is C. The umbra of the moon will fall on the Earth. We call it the umbra, but I also kind of think of it as like the shadow of the moon. That's what we're going to be seeing. Number 7. According to Kepler's third law, an asteroid in our solar system at 2 AU has an orbital period of what? The answer is none of these. And that's because our orbital period is directly proportional to our period is directly related to our orbital period. So then we can set this equal to a cubed, or 2. We're going to cube it. So this gives us 8. And that's equal to p squared. We want to be figuring out what p is. So we're going to take the square root of 8. And this gives us about 2.8 years. Because none of these are 3 or 2.8, it's going to be none of these are right. So yeah, we use this direct relation. I guess I could put this as an equal sign rather than a proportion. We're given A as our, what is it called? The semi-major axis length. That was what I was looking for. 2A is our semi-major axis length. And we want to find P, our orbital period. Cool. Last one, circle all the answers that apply. Changing the orbit of a spacecraft by firing thrusters is an example of what? Our answers are A and B. As much as we wish the Force could be real, as a Star Wars fan myself, it's not. C and D are a part of Kepler's, or C is part of Kepler and Newton's laws being melded together. Conservation of momentum is that nothing actually ever completely loses momentum, so that's not correctly here. So it's Kepler's second law and Newton's third law. All right. And our last multiple choice question. Go ahead and try to figure it out. And this comes out to be the primary physical cause of the apparent retrograde motion of the planets is E. Planets have planar orbits. So this is how sometimes we can say Mercury, or what is it? Yeah, Mercury's in retrograde. Is it looks to us as it's going backwards, but really in actuality, it's moving past a bit different, or a bit in a different speed in its orbit in what we see. And it's a bit more of a challenging question. You can think of this as like one of the harder ones. All right. So now for you, I have 2 short answer questions that I want you to try to answer. So the first one is, an astronaut is standing on the moon and looking at Earth. If the people on Earth are currently seeing a new moon, what phase of the Earth does the astronaut see? An easy way for this is to draw a diagram. Let's go ahead and do that. All right, so I'm going to go ahead and draw this out. So in order, this is our sun and our Earth, right? In order for those on Earth to see a new moon, remember that's when the entirety of it is covered, we see a new moon. Then the people on the moon are facing the Earth. With the sun being directly behind the astronaut, the Earth is going to be seen in its full phase. So it'd be basically as if the entire face of the Earth would be illuminated. If you look at your general new moon and full moon diagram, if this is what we see from Earth, this is what they would see from the moon. All right, and your last short answer question. Ooh. An ast oh yeah, typed out explanation for you. People on Earth see the moon. The moon is between the Earth and the sun. If an astronaut is looking at Earth, the astronaut is on the side of the moon facing the Earth, so the sun's directly behind the astronaut, and the astronaut sees the Earth in its full face. Um, so what did Galileo observe about Venus, and how did his observations support or refute the Copernican model? Your answer should be no more than 3 to 4 sentences long and contain a brief explanation of the Copernican model. Go ahead and pause, and I'll let you take your chance to answer it. So first, you want to remember what the Copernican model is. This the Copernican model is that all planets orbit the sun, rather than the geocentric model, which is where everything orbits Earth, right? So Galileo observed that Venus goes through a full range of phases. So if the geocentric model were correct, all of the planets and the sun would orbit Earth, and Venus would never be seen in its full phase. But we do actually see it that way. The Copernican model, that all planets orbit the sun, would give us Venus's full phase. So the Copernican model, it would support it, and that would be true. All right. So I know I went through a lot of stuff. It may have felt a bit clunky, but hopefully your midterm goes well. I am a resource if you have questions. When it comes to the midterm, I suggest you go to talk if you do have any other questions you want to talk to other students or another GSI about. Once the midterm is handed out, we can't answer any questions directly related to the midterm. If it's a clarification question, we will direct you to the professors of the course. But any other questions we can and will answer for you guys. For the midterm, remember, make sure you show your work, make sure you're using correct units. What else? It is basically open book, open note, but you are not allowed to work with each other. So use all the resources you have, but other people. And I'm sure you guys will do well. When I see you next week, you guys can have a sticker if you want. Thanks for being patient with me and our recorded sections for the past 2 weeks. Hopefully they were helpful. Going forward, our weeks will be a bit more interactive. Hopefully we'll work more person to person. I learn better that way. I'm sure you guys do too. And if you want to go to a different section, an in-person section, go for it. They won't be walking through the midterm review like I did. I had to do this because we're being recorded, but they will have a potentially fun game for you guys to play. All right, so thank you for attending. Make sure you take your attendance if you want it to count for this week. And I will see you guys next week in person.